In this video, we're going to look at creating our OTL that sticks our tentacle lines to our collision objects. Now, I've gone ahead and done the basics of this. I've created the OTL, I've recreated the OTL so that we get our nice naming convention that we set up and our color. I've connected up all of the inputs and promoted the parameters that we said we would during the setup exploration video. So that's really just some parameters related to the surface travel on the collision, like the voxel size and the noise settings for traveling across the surface of the collision. And then the ramp that controls how much the tentacles writhe as they approach the collision object. So they don't writhe as much as they get closer. Now, there are a couple of things that we can realize if we start to think about what it would be like to use this practically. The first thing is that if we're going to have this voxel size parameter here and expect people to be adjusting it, it's a little bit silly that they can't tell what the collision surface actually looks like. So that's something that we'll need to fix. It's also really hard to see the lines on the surface of the collision object. You can see that it's really bright, and that's not really that useful. If we're going to be adjusting these parameters, it's going to be really hard to tell what we're actually doing. So that's something we need to fix as well. The other thing is that it's really hard to tell which tentacles are actually colliding with the collision surface. And also, you'll notice that I haven't promoted any of the parameters related to actually telling it what the collision objects are. So if I go ahead and unlock this and dive inside, and let's just look at our inputs, you can see that it's still hard-coded to the submarines. So we're going to need to figure out how to deal with that too. The last thing I want to point out before we get started here, I'm just going to come back up to object level so that we can see what the output is if I hit play, you can see that it's actually quite slow, which is a little bit odd because really what we're talking about is a bunch of static lines on the surface of the collision object and then some noise traveling across the lines above it. You'd think that would be real time, but for some reason it's not, which means that there may be a problem with the setup. So we're going to talk about how to diagnose those kinds of oddities and see if there's ways that we can improve the setup as we go. All right, so first things first, let's talk about how to add display settings so that we can change these parameters meaningfully as users. Now, the way that I like to usually deal with this is to give people lots of options for how they want to display things on my OTL. So the way that we're going to do that is by providing a couple of different menus. I'm going to go to Type Properties, and under Parameters, we're just going to put some display settings at the top. Now, those are eventually going to feed down into switch stops, so we're just going to use integer parameters so that it can control the index of the switch stop, and we'll see how that works in a second. I'm going to make 2 of these because there's 2 things that I want to be able to display. And it would be kind of nice if the user could control the display of them separately. So we're going to control the display of the tentacles with one of these parameters, and we're going to control the display of the collision surface with the other parameter. So I'm just going to make this a little bit bigger, and then the first one we'll call tentacle display. And the second one we're going to call collision display. And we can just think about a few different options that we might want to have here. I'm just going to turn on the Use Menu option. And for 0, we're going to say maybe none, meaning that we're not going to display tentacles at all. For 1, maybe we'll display the not stuck tentacles. For 2, maybe just the stuck tentacles. And for 3, both of them merged together. And then we'll take a look at what this menu looks like in a second, but for now, let's just go into the collision display. turn on the use menu toggle. And for token 0, again, we might just say none. For token 1, maybe we can say something like the collision VDB. And for token 2, we can say something like converted VDB. And the reason why we're adding this in here is because sometimes it can be really hard to tell what the VDB is actually doing and how much detail we're actually preserving by looking at the volumetric display itself. What we really want to know is where Houdini thinks the surface of the VDB is. So in order to get at that, it's useful to see it converted back to polygons. So that's something that I anticipate my users might want to be able to do. All right, one last thing is right now they're going to default to 0, which is none for both things. And I feel like it's kind of unintuitive to have this OTL by default display nothing. So I'm just going to go to the channels tab here. And for collision display, we're going to, by default, display the converted VDB. So that's going to be token 2. As we can see, that's the converted VDB. And then for the tentacles, by default, we're just going to display merged. And you might wonder why we're not displaying just stuck as the default, since that's kind of what we care about for the purposes of changing these parameters. And the reason for that is that we're going to modify our setup to make it fairly easy to tell what those are, and therefore merged will be the easiest way to control it and see everything, at least as a default. But then if users need to, they can always switch to these. So we're going to say that token 3 is the default there. All right, now that we've set up these parameters, we're going to just hit accept to dismiss the dialog. It's just warning me that I have references outside the OTL. And that makes sense because my collision objects are still hard-coded. We'll deal with that later, so we're just going to hit OK for now. Okay, and we can see our lovely display menus here. Tentacle display, we have our nice options. Collision display, we have our nice options. So let's just go and see how to hook this up. If we dive inside, what I like to do is just make another geometry node off to the side here and call it display. And now we can just turn off our output node because this is something that's just always going to be object merged by the next OTL in the chain. And this is just the one that's going to be displayed. All right, so we're going to be creating a lot of object merges inside this display node. So let's go ahead and make some nulls in our stick to collisions node to use as hooks for those object merges. So let's go in here and go ahead and make some nulls. So the first thing, if we deal with tentacle display first, we have not stuck here. And what we're going to do, I said that it would be nice if the merged option made it clear which ones are stuck and which ones aren't. And the way that we can do that is by simply coloring them. So I'm just going to go in here and say that the not stuck chain is going to be colored, let's say blue, because what they really care about is the stuck ones. So even though it's going to be still displaying the not stuck ones, we're going to color them a darker color so that it's easier. We're going to color them a darker color so that the stuck ones stand out. So we're just going to make that blue, if I could type. And then I'm going to color the stuck ones red. And that makes it fairly clear that these ones are stuck and these ones are not. And if I just advance over, we can see that the ones stuck to the submarine are also nice and red. So it's easy to tell which ones they are. And now let's just go ahead and add our nulls that will serve as hooks for our object merges for our display node. So this will be not stuck out. This will be, we do a null. stuck out. And then if we go over to our VDBs, this is what our VDB looks like. So this is what we want to display. So I'm just going to add a null here that says collision VDB out. And we'll do our convert in the display node because we don't actually need it for the setup itself. So there's no use doing it here. Now it doesn't matter because we have an output node, but I'm going to go ahead and just put the display flag back on the output here, just for the sake of cleanliness. And let's just go ahead and come back out and set up our display node. So we'll need an object merge for not stuck. We'll need an object merge for stuck. And those are going to be, remember to always export relative paths. And under stuck to collisions, we can see that we have our not stuck out here, so we'll just reference that. And then for stuck, export relative path, stuck out. There we go. Now I'm going to make my switch. And the 0 part needs to be just nothing, so let's just go ahead and make a null and call it oblivion so that it can sit there in the first input. The second input is not stuck, the third input is stuck, and then the fourth input is merge. So I'll just name this switch swap something like tentacle display, and just hook it up to my menu with a channel reference. We want to go up 2 levels to get to the OTL's interface, and then we just say / tentacle display. Okay, and then we can just evaluate the expression here so that we can tell that we're getting a 3, and we can see that we are in fact getting the merged tentacles. So that's pretty great. Now I want to set up the collisions. So I'm just going to copy paste the oblivion null here because I don't want to have some wire from another switch swap coming over here and crossing over all of these wires. It'll be a little bit messy that way. Going to make another object merge, call it collision VDBs, export relative path, collision VDB out. And then before I go on, I'm going to just select all of these object merges and change transform to into this object so that we pick up the transform that's coming in from the first input. All right, let's make our switch. Call it collision display. The 0th input is oblivion. The second input is the VDBs. And then we're going to just do a convert VDB to get back to geometry and just change the convert to polygons so that it does make geometry. And then we'll just drop that into our switch. And then since these two things are displaying different things and we want to display them both at once, we'll just do a quick merge to add them all together and then set the display flag. And of course, I haven't set up the channel reference on the display switch yet, so we'll say ch collision display. There we go. It looks like my converted VDB doesn't have normals, so we get some really odd lighting. So I'm just going to go ahead and use a facet swap to compute normals on it so that we get normal display. And then let's just put an output node at the end for cleanliness. All right, so something that's a little bit interesting about this is that this is still really hard to see. And no matter what options the user picks on the interface for display, it's going to be really hard to see these red lines traveling across the surface of our collision mesh. So what we'd like to do is make it a little bit easier to see by just making it really dark. And we can do that with another color sop. So I would like to have this happen on both the geometry and the VDB itself, just because it's easier to see that way. So we're going to use two color sops. The first one is going to go for just the VDBs, and the second one is going to go for the converted surface. So let's do a color here, and we'll make it pretty dark, like not 0.2. We'll just do like a dark gray color. I'll move these, put another color here. And maybe we can just channel reference. Copy parameter, paste relative references. And that makes it a little bit easier to see. We can also just hit W to go to wireframe mode to see what our lines are doing across the surface of the collision mesh. Maybe I'll even make it darker. So that's a little bit easier to have it stand out. Yeah, that's pretty good. All right, now that everything's all wired up, let's just try out our display modes. If we come back out to object level, we don't want to forget to save our node type as we go, because we just made a bunch of changes inside that haven't gotten saved yet. And notice that I still have my original collision object displayed, so we're going to go ahead and turn those off, both the terrain and the submarine, so that we're looking at the one from our stick to collisions node. And it seems like we can change our menus and get the things that we want. Switch off wireframe mode so we can see the actual VDB itself. Can turn off the collision display and just see the lines, or we can show the converted VDB. All right, so the second topic of this video is how do we create an object merge that will merge all of our collision objects. Now we could just tell users, well, you have to make another geometry node that just contains all of your collision geometry all at once, and that geometry node would just object merge these, and they can do that by hand. But that's a little bit inelegant. I think better style is to put those kinds of things in a multi-parm block on the node itself. And then what we'd really like to do is use our getOutput expression to get the outputs of each node they reference, so that if we end up making custom OTLs to deal with collisions, we'll be using our standardized way of getting outputs from other OTLs to grab that geometry. All right, so how do we do this? Well, the first thing we want to do is make a multi-parm block in our parameters. And you might be wondering why I don't just go in here, and we're going to scroll up to where those inputs are. Maybe put them down here. Put this down here because it's kind of weird that it's so high up. You might be wondering why I don't just make an object merge. Let's move this over here for a second. Make an object merge and just drag this multi-parm block up into the interface. And in fact, we could do that by going to from nodes and finding it in there and just dragging it across. And that would work, but it's a little bit non-trivial in that case to make a custom expression on the parameter here. And also I'd like to show you the hard way of doing it just so that you can see some extra techniques. All right, so I'm going to make another folder here. And this folder is just going to be called collision objects. And for this, we're going to make it a collapsible section. If I hit apply, yes. Come back up. Of course, there's nothing in the folder for now, so we need to put something in there before we actually see it on our interface. So we're going to put another folder. And call this number of objects. And this folder I'm actually going to name as if it was another parameter as well. And the reason for this is that we're going to make this our multi-palm block. All right, and then inside this, we're just going to have a operator path, which we will call collision object number. And if you aren't familiar with how custom multi-palm blocks work in Houdini, the number part of the name or the label is just going to be the number of the current instance of this in the multi-palm block. So as we keep adding them, this is going to increment from 1, 2, 3, 4, 5, 6. And for label, we'll just duplicate the name. And let's go ahead and just hit apply. Yes. All right, and now our collision objects are here. I'm gonna go ahead and expand it. Here's my nice multi-palm block. I can add additional collision objects. And you can see that it increments 1 and 2 like this. So let's just go ahead and reference our submarine and just collapse this for now, our submarine and our terrain. And then look at how to hook this up down inside. Now, before we dive in, I just want to point out that these geometry nodes do in fact have output nodes on them. And it doesn't matter that these are also nodes of type output. What matters is that they're named output in full caps. So our get output expression is going to find them. All right, so let's just go ahead and dive inside here and look at how to hook this up. The first thing I'm going to do is change transform into this object. And let's just change our object merge to have our blue color to denote that it is an input. And I'm going to go ahead and name it get collision objects. Now, one of the sort of hidden features of object merge is that in the object field for any one of these instances of the multi-palm block, you can actually provide a space-separated list of operators, and it will merge everything you specify. So if I just cancel this to dismiss this dialog, and then put the display flag here and show you how it works, we do have a template flag set here, so I'm just going to clear that really fast. And let's just grab submarine. Come on, Houdini. And terrain. You can see that I've merged both of them. So what we want to do is just create a Python expression that returns a space-separated list of node paths. And then object merge will know what to do with that. So we don't actually need to use the multi-palm block inside. So in order to make a Python expression, I'm just going to switch the default language of this node from HScript to Python, so that we're going to be creating a new Python expression instead of a new HScript expression. And since this is a string parameter, we need to actually manually create a keyframe in order to put a Python expression on it. So I'm going to Alt-click on it to create the keyframe that's going to hold our expression. Now I'm going to click in here and hit Alt-E just to bring up the Edit Expression dialog. And you'll notice that it's just put what was already there in quotes here, We don't actually want that, so we'll just get rid of it. Now, if you recall, our expressions module is always imported, and we can check that by, I'm just going to hit Alt-Shift-P to bring up my Python shell, and just say expressions.get output, and it does find it. It's always imported, so we don't have to import it in our expression here. All right, so the first thing that we want to do is grab our parent node. So I'm going to say parent equal who.node. In fact, if you remember in Python expressions, we don't need the who dot part. We can just say node. /. And then we'll just say num objects equals parent.eval_parm number of objects. And now that we know the number of objects that we need, we can just start our for loop. Now, note that this num objects is going to be the number of objects starting from 0. But the names of our parameters in our multiparm block are going to start at 1. And we can just see that on our interface here. We can see that this is collision object 1, this is collision object 2. So number of objects right now is 2. But we need to actually create something that goes 1 and then 2 so that we can read these parameters. So the way that we can do that is by, I'm just going to go to a new line and say for index in range, range being a Python function that will return a list of numbers in sequence. And what we can do is just tell it to start at 1, and then go to num objects plus 1. Of course, I need objects, not object. So that'll make a range that starts at 1 and then goes to num objects. And we just add 1 to num objects so that we have the number of objects if we start counting at 1 instead of at 0. We're going to do a colon. And we're just going to get the current path. So if the index is 1, we want to get collision object 1. And if the index is 2, we want to get collision object 2, right? So all we have to do is just say cur path equals parent.eval_parm. And then give it the name of the parameter, which is collision object underscore whatever the index is. So we'll say collision object underscore. I'm just going to use format syntax here. .format index. And this way we'll be telling Python to replace this part of the string with our index. That's what our format function is doing. Now we just need to accumulate these paths into a list. So I'm going to say path list equals empty list. And then during our loop, each time we get a new path for the index that we're currently running over, we're going to add it to our path list. So path list dot append cur path. All right, and then we can just return space dot join path list. And if I hit apply, let's go in and see what had happened. Of course, it does seem to be working, but let's just see what it did exactly. So this just returned our raw paths, which is kind of what you would expect. So right now we haven't done anything better than just directly promoting and linking the multiparm block itself. And if you remember, we said that we wanted to use our getOutput expression on this to get the full path to the output node. So the way that we can do that is actually quite simple. We have our cur path here. So let's just modify it to say cur path equal expressions dot get output cur path. And hit apply. And of course, our expressions module is not available in the actual Python expressions. It's only available external. So we just need to go here into the top part and say import expressions. So we'll just hit apply. And now we get, let's hit close to dismiss the dialog. Now we get our nice output paths. All right, I'm just going to set the display flag back down here onto output, just for the sake of cleanliness. And let's just look at one last thing now that we have everything hooked up and our display is working. There is the matter of this pesky slowness, and it really seems kind of bothersome. Another thing that's a little bit weird is that we have some global controls for what shape the lines take as they travel across the surface of some geometry. But we have two different collision objects, and we can anticipate that users might want the lines to travel across the surface of the terrain differently from how they travel across the surface of the submarine, especially if we consider that a submarine might be some sort of like hero object that the camera is going to be focusing on in our shot. And we want to have the tentacles make a cool pattern as they travel across it. Now, one of these improvements might be quite easy to do, and the other one might be quite hard to do. When we're converting setups into OTLs like this, it's a good idea to prioritize our time. We want to make sure that we get the task done quickly and on time. So if it's something that seems like it's going to be a quick improvement, we want to go ahead and do it right away. And if it's something that it seems like it's going to take a long time, which is the one that requires a deep understanding of the setup and modifying it to a pretty big degree in order to get it so that the lines behave differently depending on which collision object they're going to strike, we might just go ahead and finish off the setup first and then come back and modify it if we have time. And when we're doing this sort of thing under production deadlines, we want to be constantly evaluating, is this really worth it? Speeding up the setup is definitely worth it if we can do it quickly. Adding these sort of fancy features to make things travel differently for different collision surfaces, while useful, may not be that necessary, because what people could also do is just split up the emitter and create two separate setups for one for each collision surface. So having decided that we're going to postpone our collision controls, let's go ahead and see how we can try to improve the setup by speeding it up a little bit. And the way that I like to do this is I like to kind of step through the setup and try to find where it starts being slow. So if we start up here with get lines and just hit play, it's real time here, which is what we'd expect because it's really just lines with noise on them. So I'm just going to go ahead and actually leave the thing playing, and we're just going to go ahead and step through. All right, if you remember, the way that I usually like to step through setups is whenever I see outputs branching like this, I like to try to understand the meaning of the branches and go to wherever they merge back together, if they do, in order to try to see what's happening. So I'm just going to jump down to there. And it looks like whatever is happening over here is still fast, so we don't really care about that so much. Now we have isolating stuck and isolating not stuck. Of course, not stuck is still real time because it's just a blast and a color, so that's a pretty safe bet that that's not what's slowing it down. So let's just go ahead and step through the stuck part. Looks like it's still real time. Let's just skip the for each block. Aha. Okay, that is really slow. And interestingly, it's really slow for something that's not even moving anymore. So that's kind of problematic. And it looks like all these things aren't moving, but they are still time dependent. And we can see that by seeing this little clock icon here. So before we go and change the setup too much, it's also possible that just the attributes are animating. So I might just right click and go to spreadsheet here and just take a quick look at my attributes when we start to hit play. And it does look like they're not animated. I don't see anything moving. Okay, it seems fine. So let's just try putting a time shift in and see if switching this to no longer be time dependent is going to work. So I'm just going to do a time shift. Let's see if it changes the setup at all. Let's just make the frame $f start. And it looks like if I put my display flag back on output, it makes everything up to the part that retrieves the writhing not time dependent anymore, which seems like it kind of makes sense. Like, this is just making the lines travel along the surface. I don't know why that would be time dependent, because they're static. All right, so if we hit play now, we have made it real time, so that's pretty cool. But let's just see if we look at a few example frames. I'll just maybe take 4. So let's just look at frame 1 first. We're going to turn on and off the time shift. It doesn't look like it's changing anything. Let's go a quarter of the way through. Doesn't look like it's changing anything, and you get the picture. It seems like it's really fine. And this seems like a thorough enough test that we can be fairly confident that adding this time shift here hasn't actually broken anything. And of course, the real test would be once we actually finish the setup, we're going to be doing a render and making sure that it matches the original output of the setup itself. All right, so that is our stick to collisions OTL. In this video, we looked at some ways to set up display settings on our OTL interface. We looked at how to hook up multi-parm blocks in a slightly more creative and a flexible way than simply promoting parameters. In future videos, we're going to finish off the tentacles setup. We're going to be looking at how to improve our stick to collisions OTL even further. And we will look at some further ways to automate our setup.